In this lecture, we're going to see that we can use our own class objects as exceptions, but those class objects are going to be part of an inheritance hierarchy. Here we have a simple example of our inheritance hierarchy. We have our base class to be something's wrong, something we have done in the last lecture, and it is going to have a member variable which is going to be protected. And we can use this as a base class for our objects that we can throw as exceptions. For example, we can create a warning class which is going to inherit from something is wrong. So this is not going to do anything special. It is just going to forward construction to something is wrong. We can derive from small error and create a critical error class that we can use in our inheritance hierarchy. One thing I want you to be aware of is that we can use these guys as exceptions. For example, we can throw a critical error object as an exception. This is something we can do. We can throw a small error object as an exception. This is something we can do. And we will try this out in Visual Studio Code in a minute. You're going to see that this is going to work out pretty well. But you need to know that if you use a bunch of catch blocks to handle these things, the order in which you put these objects is really important. Because if a base catch handler shows up before all the others, it is going to catch all the exceptions, and you want to get good error messages for your exceptions here. So the recommendation is to order these catch blocks from the most derived all the way to the most base. You can see that critical error is first here, small error is second, warning is first, and the last one is something is wrong. This is going to give all the catch handlers here to work if we happen to throw a most specific error in our function that we are running here, which is wrapped in our try block. Now that we have an idea about this, we are going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. We are going to work on the project here where we use exceptions as class objects with inheritance hierarchies. We are going to grab our template files. Let's do this pretty quick. Let's put this in place, and we are going to open this in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean this up a little bit. I am going to set up a new file which is going to contain my inheritance hierarchy for my exception classes. So let's put in a header file and call it exceptions.h. This is going to be a header file, and I'm just going to put in the content here, nothing complicated. We have a class which is going to be our base class. This is exactly what we had from the last lecture, but we can derive from something is wrong and create our warning class, which is right here. We can derive from warning and create our small error class, and we can derive from small error and create our critical error class. Each of these is going to put in a function called what, which is going to return whatever is wrong that caused us to throw an object of this class as an exception. And we are going to customize this a little bit. For warning, we are going to add a yellow to mean that warnings should be yellows in our program. For example, for small error, we're going to say orange. And for critical error, we're going to say this is really serious. We're going to put a red here to try and make this a little bit interesting. Okay, now that we have this, we can include this from our main CPP file. Let's do that. We're going to include exceptions.h. This is our header, and we're going to set up a function which is going to be throwing objects of our classes in our inheritance hierarchy. For example, we can throw critical error, small error, and warning. Let's make this a warning. The last one here. This is going to do, and we're going to say that I is 4. We're going to do this at index 4. And we are going to go in the main function and set up a loop which is going to be using this function here. So let's go down and actually do this. We're going to go to the main function and put in a piece of code which is going to loop 5 times. It is going to be looping from 0 all the way to 4. And we are going to have a bunch of catch handlers which are going to catch objects of our inheritance hierarchy. We have a critical error, we have a small error, we have a warning, and we have something is wrong, which is our base class. You're going to see that all these guys are going to be code, and this is going to work really well. Let's make sure this runs. So let's pass this through GCC. our favorite compiler, and we're going to have a bunch of warnings. So what is going on here? And we are returning a reference to temporary values. And we are doing this in our exceptions header, as you see down here. So let's go there and see if we can fix this up. We are in our header here, and in our inheriting classes, we are returning references to temporaries. If we add a const char pointer to a string, we will get a temporary, and we will return it here. This is the problem. So to make the compiler happy, we can change this to be a copy anyway, because it is a temporary. I don't think it is a big problem to copy that. And if we return a reference to a local temporary, this is going to be a problem. So we can make this a copy to make the compiler happy and return by value here. We're going to do the same thing for all our what functions that we are setting up in each of our derived classes here. So let's do the same for the what function from our critical error class. And one thing I should point out is that what we have in our derived classes is completely hiding what we had in our base classes. So for example, the what function we have in warning is going to hide what we had in something is wrong, and the same is going to happen in small error and critical error. All these functions at most derived classes are going to be hiding whatever functions come from the upstream classes. And let's make sure they have the same signature. So we are also going to return by value in our something is wrong class. So we are going to return a copy. And hopefully this is going to make our compiler happy. Let's pass this through GCC again. And now we are happy. The build is good. Now, what I want you to see is what happens if we run this program. Let's make sure we do that. So let's clear and run rooster. We are going to see that at index 0, we're not going to do anything interesting. At 1, we're not going to do anything interesting. But at 2, we are going to throw a critical error. And it was caught by our catch block that catches a critical error here. That's why we see this message, and it is red because a critical error should be red. At index 3, we are going to throw a, let's see what we throw at 3. We are going to throw a small error, which is going to be orange. And at 4, we are going to throw a warning, which is going to be yellow. This is what we set up in our program here. But watch what happens if we try and put our something is wrong catch block in front of everything. Let's see what happens. So we're going to do that here. And our catch block is going to show up first. Let's try and build and run, and you are going to see what happens here. And we have a warning. What is this warning here? The warning is going to say exception of type critical will be caught by earlier handler. And this is something I want you to see here. Now, we have a more generic or a more general catch handler, which is really going to catch everything we throw from this function, because anything we throw from this function is going to be a something is wrong object. Because all these objects, critical error, small error, and warning, are deriving from something is wrong, the first catch block is really going to catch them all, and we want to get more specific error messages that we can print. Let's make sure we run this because we have built this successfully, even if we had a bunch of warnings, but the build was finished. We had our rooster.exe binary, so we can run it. Let's make sure we do that, and you're going to see that for everything, we have something is wrong code. Okay, for I is 2, 3, and 4, everything we catch is something is wrong because the first catch handler we have can really catch everything in here because all we throw is really something is wrong derived class objects. Hopefully you can see that it is really critical to catch the most specific first and catch the most generic last, like we are doing here. That's what we're going to do, and it is going to give us a more reasonable setup that is going to give us meaningful error messages when we throw these exceptions in our C++ program. Let's make sure we build again. So we're going to pass this through GCC to make sure we don't have that error again. And it looks like we have a problem here. What is wrong? So let's make sure we Control Z a couple of times to bring this back to a state where it was working properly. Now something is wrong is last, which is what we had before, and it is what we want. Let's pass this through the compiler to see that the build is good now. Everything is good, and we have a more general catch block at the end. Let's make sure we run this. So let's view our terminal, and we're going to clear and run Rooster, and now everything is working correctly. This is what I wanted you to see. If your exception objects are part of an inheritance hierarchy, it is really good and advised to order your catch blocks from the more derived to the more generic or the more base catch handler, and that's going to allow you to have more meaningful error messages. Otherwise, the most base one is going to catch everything, and everything is going to be cramped together, and it is really not going to make sense. That's the point I want to make here. This is really all I wanted you to see in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to show you that we can set up something like this that is using dynamic binding. And in that, we are going to make all these what functions virtual, and we will let the compiler decide which one to call at runtime using dynamic binding. That's going to make things easier because we won't have to set up all these crazy catch blocks that we are doing here. Go ahead and finish up here and meet me there.